In this video we're learning how to sketch some simple parabolas using factorization as our starting point. Now think if previously we've been looking at turning point form equations and sketching the parabolas, taking on board the transformations A, H and K. That's fine, but what if you're not given the equation in that form? Well, one of the things you could do if you're given the equation as a expanded monic. Okay, we're going to look at just monics in this one where we have a 1 there. Okay, so A is 1. We've got a B and a C, it's expanded out. What do? Well, one thing we can do is the following 4 steps. And basically the first step, this is not, by the way, it's not the only procedure for doing this. This is a straightforward procedure, so something good for middle high school level, for students who are just at the beginning of senior or even at the end of the middle phase of learning. So basically, because there are more sophisticated ways than this, but anyway, this is quite a reasonable, straightforward way. So first thing we can do is find the y-intercept. So the y-intercept happens when x equals 0, as you already know. Second step is we find the x-intercepts or intercept. As you might know previously with parabolas, there can be 0, 1 or 2 intercepts, x-intercepts, which are also the solutions. That happens when y equals 0, and in order to do that, in this particular video we're going to be looking at factorizing and solving. In that step, we're going to look at ones that can be factorized. Now if you had a tricky one, by the way, you could use the quadratic formula, but because that will get you solutions as well. But that's not really for this video. We're just sticking to ones where we can factorize. But just know that if you had one of awkward numbers that didn't factorize, you can use a quadratic formula. So factorize and solve, and of course the equation has to be set equal to 0 for that reason. By the way, in the first step of the y-intercept, that's a case of just the algebraic process involved in it. It's just a bit of substitution, where it's solving in the second step. Okay, so step 3, we use step 2. So you'll get 1 or 2 or even 0 solutions. It's not very useful if we get 0 solutions, but we use the solutions or solution in step 2 and symmetry, because parabolas are symmetrical about the axis of symmetry, which you know already. Step 2 and symmetry to find the x value of the turning point. So it'll give you the x value of the turning point. Now if we've got the x value of the turning point, we're then ready for the final step, which is the y value of the turning point. So use step 3 and substitute in x to find y, because it is a turning point, so it needs an x and a y to make the coordinate. Now once we've done that, we're ready to sketch. So I guess there is a 5th step. Use all those bits of information from above and sketch. Let's say we had to sketch this monic quadratic here in expanded form. So let's follow those 5 steps and go ahead and do that. So step 1, the y-intercept. So y-intercept, make x equal 0. Okay, so y will equal 0 squared minus 6 by 0 plus 5, which is 5. So the y-intercept is 0, 5. So there's 1 point. Okay, the second step is the X-Intercepts. Whoops, X-Intercept. So we make the equation, or y equals 0. So 0 equals x squared minus 6x plus 5. Now one thing we can do here is factorize, and that's the method we're concentrating on in this video. So let's do that. We go to one way of doing that is to decompose the middle term. So we can say it's x squared minus 5x minus 1x plus 5, and then we've got x outside of x minus 5 minus 1 outside of x minus 5. I'm assuming you know factorizing quadratics, otherwise you're not watching the right video. X minus 1, x minus 5 is factorized. Now of course that equaled 0 the whole way through, didn't it? So null factor law. Two things multiplied together equals 0. One or the other's got to equal 0, or both. So we've got the null factor law means x equals 1 or x equals 5. Okay, so there are our two solutions. So it cuts through, that's actually the point, in fact that's the point 1, 0 as a point, and that's the point 5, 0. Rightio. So the next step then is to use those points and use symmetry, and basically the x value of turning point. Basically you want to find the middle of 1 and 5, so one way of doing that is add them together, divide by 2, find the mean of it. 6 over 2 is 3, so the turning point's 3 something. Alright, so the turning point is 3 something. Well, to find that something, we do the fourth step, the y value of the turning point. We basically sub that 3 into the equation, alright, and it will give the corresponding y. So the equation, just remember, was written above there. It was x squared minus 6x plus 5. So y equals x squared, so that's 3 squared minus 6x, so 6 by 3 plus 5. Okay, and it comes out as negative 4. So the whole turning point is known now, and it's 3, negative 4. Yay. So what we do is we get all of that together. As you can see, we've got some information now. We can use that point, the y-intercept, the two x-intercepts, and the turning point, and we can plot our graph. So I've got one already done there. You can see that it uses those points as I mentioned. Okay, so it's got the y-intercept, it's got the two x-intercepts, and it's got the turning point, and we know that it's a nice symmetrical smooth shape, and we can make a reasonable sketch. So that's one easy, reasonable way of sketching a parabola if we don't have it in turning point form.